Thank you very much, Luke. Good morning, everybody. I'm glad to see a lot of people in person, and I'm also very glad to speak in person to you. It's different from being online and not seeing anybody. So I'm very glad to be here, and I hope I can show you a little bit about what we do in Berlin in terms of recycling. My topic will be to look at partially closed water cycles in the city of Berlin. And I would like to also mention my co-authors, Sebastian Schimmelpfennig, Ruth Bittner, Ulf Mier, and Steffen Keller from Berliner Wasserbetriebe and Kompetenzzentrum Wasser Berlin. I will show some results that they also generated. So the city of Berlin is situated in the eastern part of Germany. We have two rivers running through the city. This is the river Spree and the river Havel running from north to south. We have a population of 3.7 million inhabitants. The area is about 900 square kilometers. We have a precipitation, an annual precipitation in general, or an average, long-term average of 570 millimeters per year, which is not very much, as I will also show you. And the discharge of both rivers in sum is just about 50 cubic meters per second. So we say we have a lot of rivers and lakes, but we have little water in Berlin. An historical example for water reuse are the so-called wieselfeld. I think everybody is familiar with this term, sewage irrigation fields located on the outskirts of the city. Wastewater was pumped from the city center to the outskirts where it was used without any treatment, 1850, something like that, to irrigate fields, and the farmers there grew very large tomatoes and cucumbers and everything. It was quite successful, but 100 years later, people had a closer look what happened. This is a geological cross-section, so we have some aquifers which are separated by a little bit of glacial till in between. This is about 50 to 70 meters in depth. And we see that looking at some trace organic substances, this is chlorhibric acid. Yeah, it's a blood lipid regulator that was used very much in the 60s, 70s, 80s, something like that. We see up to the third aquifer, up to here in this region, we find very distinctive concentrations of chlorhibric acid. This was found in the 1990s, end of the 1990s, and so this showed what a large impact the irrigation with wastewater had on the groundwater in the region. And not only due to this, also due to the fact that wastewater treatment plants were then installed. Sewage irrigation came to a halt in the 1990s of some 30 years ago, 20 years ago. So what does drinking water production look like in Berlin right now? So we have, as I told you, the wastewater treatment plants are located on the outskirts of the city. These are the green dots, and the blue dots are the drinking water treatment plants, and the red lines here are our well fields. They are located along the rivers and lakes of the city. And this is a picture over there. This is what a well looks like. It's quite close to the river or lake. So we draw about 70% of the surface of the water that we produce is originally surface water. And this surface water is also influenced, of course, by the discharge of the wastewater treatment plants. This is what we call the partially closed water cycle. This is what a view of the city looks like. So we do have not as much water as we have in Amsterdam, but of course we do have some lakes and rivers running through the city. However, if we look at the discharge of the rivers compared to the inhabitants, In different German cities, we see that Berlin, we have about 1 cubic meters per inhabitant a day. Compared to other cities in Germany, it's very, very little. So the discharge that we have in surface water is quite little. We have a lot of weirs that keep the water table stable, but in terms of dilution for treated wastewater, it's not very much. This is a very schematic a drawing of the shares of treated wastewater in the surface water, and we see coming from lower than 1% as the river runs through the city. Yeah, the wastewater treatment plants discharge their treated effluent into surface water. So when the river exits the city, we have about 11% of treated wastewater, and this is just the annual mean. So in certain low flow situations, we have even higher shares of treated wastewater. And up here, this is a special situation. Close to Lake Tegel, we have due to the fact that the the wastewater treatment plant sewage, Schöner Linde, discharged into a lake where there's very little flow, we have nearly 30% of treated wastewater in the surface water, which we use for drinking water production. This is the same, just a little bit more detailed. We have the waterworks, we have the wells located along the banks of the river. The water is used by the people, goes to the sewage treatment plant, and then is discharged, or used to be discharged, into some small creeks into the lake again. So these are the different waterworks that we have in Berlin. And this one is the one where we have the highest share of bank filtrate compared to ambient groundwater, the highest share of treated wastewater and surface water, and as a quantitative balance, the highest share of treated wastewater in the raw water that we use for drinking water production. What does this mean? Again, trace substances that were also found in the sewage irrigation fields. We also find them in drinking water. We have valsartanic acid, gabapentin, oxyproinol, candesartan, carbamazepine, which a lot of people know, PFOS, phenazone, benzotriazole, all in very low concentrations, but in concentrations that we can measure, and we actually would prefer not to measure it. And what is happening? We have extended drought periods, and this is something that we had in 2018. And if we look at the average, including a long time, the share of treated wastewater that we measure here in the lower half is not 6%, but it's actually 11% in a long-term average. So if we have low flow conditions, the share of treated wastewater, of course, will rise. Looking at future climatic developments, I don't have to tell you the temperature is going to rise. These are a lot of projections for the future. And although the annual precipitation in Berlin, there's not a clear trend in terms of less precipitation or more precipitation, we see that we have a lot of variations, and due to the fact that we have rising temperatures, of course, we will have a lot of more evaporation and less water for groundwater recharge. Getting the broader picture, this is a study by Jörg Treves from Munich University, and he looked at the share of treated wastewater in surface water in Berlin, in Germany. This is Berlin up here. So if we have medium flow, we have just very few spots where we have quite high shares of treated wastewater. But when we look at low flow conditions, we see that very many of these smaller rivers along the Rhine, and also here in northern, but also in central Germany, the share of treated wastewater goes up to more than 50%. So it will become more and more important recycling or having treated wastewater in your drinking water source. And this is with all the issues that come with it. In Berlin, we solved the problem that, that we had these high concentrations, or comparatively high concentrations of trace organic substances in the waterworks. We did this by decoupling the wastewater from the drinking water side, but on the long term, we're going to build, or we're right now already building, an ozonation plant with associated biologically activated carbon to be completed in 2024, so that we eliminate most of the organic trace substances and that we can use the water which we need from the quantitative point of view. We need this for also for drinking water production. This is just the last slide from an R&D project called Aquanis. Ulf supplied this slide. I don't have to go into detail about the different classes of the Water Reuse Directive, but they did experiments with the ozonated wastewater in terms of the standards concerning the different parameters. And we see that ozonation plus constructed wetlands reaches limits of lower than the limit for E. coli for Class B usage. And the same is true also for total suspended solids and turbidity, meaning that restricted irrigation is possible, and according to the Water Reuse Directive. However, due to the experience that we have in Berlin, we think that this is not sufficient. We also need to have a look at the trace organic substances that will always be part of the treated wastewater if we don't have extensive treatment. So to sum it up, we have intentional or non-intentional water reuse with a long tradition, also in Central Europe. The partially closed water cycles, they exist at many different scales. And however, we think that different categories of usage should be defined by water quality, not by water source, as surface water sometimes can be very very strongly influenced by treated wastewater. Sensitive areas, for example, drinking water resources, need to be regarded separately, and the criteria should also include the organic trace substances, the persistent mobile and toxic substances that are in discussion in the REACH regulation. Enhancing water reuse will help to minimize our water footprint, which is good, and to enhance climate's resilience, especially during low flow conditions, during periods of drought. We will need to use the treated wastewater not only for irrigation, but probably also to supplement our drinking water resources. However, we should have a very close look at the persistent substances. They should not enter the water cycle in order to make it usable. And of course, the carbon footprint needs to be regarded as well, because at the same time, we want to reach carbon neutrality. And this is, I think, the biggest challenge that we have for the future. Thank you very much. And I'd be glad to answer any questions if there are any.
Is there a burning question?
Hello. I'm not a water engineer, so it might sound like a naive question, but in the UK at the moment, there is a big problem with uncontrolled discharge. I mean, discharge of untreated water. The situation is quite similar overall with, you've got less water in the rivers, and with climate change, you might have heavier rainfalls, so suddenly you've got the wall of water coming to the wastewater treatment, which cannot process all that, and therefore let some untreated water get in there. And I've not seen in your slide what happens with the uncontrolled discharge. Is there any such thing?
Combined sewer overflows. You mean combined sewer overflows. Yes, it is, of course, an issue, and we expect, as you say, more of them to happen in the future due to climatic changes. However, we're putting a lot of energy in trying to avoid these combined sewer overflows. We're building large reservoirs where water can be stored to be later then treated in the sewage treatment plants after the strong rain event. But in addition, we're also promoting decentralized stormwater management solutions like green roofs, infiltration, etc., so that in the city itself, the stormwater does not go into the sewers but stays or remains more or less where it is and evaporates, for example, which will also enhance the better climate in the city. But of course, this is a long way to go, and I think as strong rain events continue to become heavier and heavier, we're sort of always running behind. Yeah, so we're trying, but I'm sure that we're not doing enough right now.
Okay, thank you. I just had one question, and that's about the ozonation. You proposed ozonation for the treatment of the persistent compounds. But what about bromate formation and the new regulations? Yeah,
we had a very close look at that, of course, because that will really go through our bank filtration, and we don't want to have it in our drinking water. The bromide concentration in the treated in the wastewater is comparatively low. And if we dose ozone up to a certain level, I think it's 0.7 milligram per milligram DOC, we don't have bromate formation in a significant level. So we regulate that, or we control that with our ozone doses.
Okay. Thank you very much. Okay, then other questions. I think last one, short question.
Thanks for your presentation. I understood that you have chosen for the removal of trace organic contaminants at the wastewater site. You may also use advanced treatment and the drinking water site. Was there any evaluation? What is the best solution? It's always a problem where to interfere in the water management.
Yeah, and of course our colleagues from the wastewater side said, well, if you have a problem in drinking water, well then put your treatment in the drinking water side. So that was a discussion, and however, we said there are a lot of synergies. If the treatment is, first of all, so different reasons. First of all, of course, putting it in the drinking water, on the drinking water side, is sort of the last solution. Yeah, you don't have any further barrier to the customer if you have a barrier on the drinking water side. We would prefer to have it, of course, as close to the source as possible, to have a buffer in between, and the good thing, and I think that is also a very valid argument, is that if we have treatment on the wastewater side, we also protect the water resources. And this was very strongly promoted by our administration of the city, saying, okay, we also don't want to have these trace organics in surface water in order to protect the ecosystem. So that was the win-win situation then for us.
Okay. Thank you very much.
You're welcome.
Other questions we do during the coffee, but thank you very much.